Hi, my name is Kate, and I'm going to be discussing dark matter.
The vast majority of the things we surround ourselves with on Earth are comprised of visible matter. These are things like your protons, electrons, and neutrons, which come together to make up other things you can see and feel. But what if I told you that visible matter makes up less than 5% of the universe? All of Earth, not to mention every other star, planet, asteroid, and alien, makes up less than 5%. So what's the rest? The rest of our universe is made up of dark matter and dark energy, with dark matter being about 20% and dark energy making up about 75% of our universe. Today I'm going to be focusing on dark matter. Dark matter is matter which exists in our universe which is invisible to all kinds of electromagnetic radiation, including light. Dark matter isn't just matter that you can't see. For example, when Harry Potter pulls on his invisibility cloak to go sneak around Hogwarts, he doesn't turn into dark matter just because he can no longer be seen, as he can still cast a shadow and he can be felt through the cloak. Dark matter is much more than just invisible. It's as indecipherable as the air around you when it's 70 degrees and has not a single gust of wind. It's literally impossible to see, feel in any way. So how do we know that dark matter really exists? Take a spiral spinning galaxy, for example. Say there's two particles, one closer to the center and one farther away. To compare these two particles' movements, we can use Newton's theory of gravity and Newton's second law. G, the gravitational constant, and the two masses on these two particles, we can assume to be the same as the particles are identical. So the only thing differing between them would be their distance from the center, so one having a small radius and one having a large radius. The one with a small radius would end up having a large force, and the one with the big radius would have a small gravitational force working on it. We can then use Newton's second law to see that the one with the large force working on it would also have a large acceleration, and the one with the small force would also have a small acceleration. If we assume both have been spinning for the same amount of time, then a small acceleration would equal a small velocity, and a big acceleration would equal a larger velocity. But when scientists began to study these movements, they found that the particles actually were moving at close to the same velocity. Because both started out with the same amount of regular matter, scientists have concluded that their equal velocities could only be possible if the outer masses were experiencing the gravitational effects of an unseen matter. This proves the existence of what we now refer to as dark matter. The majority of information on dark matter still has yet to be discovered, and theories abound on how it can exist within our knowledge of gravity. Some scientists even suggest that dark matter could be explained by altering our current theory of gravity, but you're going to have to hit Newton over the head with that one.